I'm so glad to be back for Module 2 of Programming in C. I'm your professor, Professor Fiske, and I look forward to continuing our conversation about C and how that works for us. In this module, I really want to go into the idea of flow control. So let's start off at the beginning. What does that mean? Flow control is something I spoke about in passing in Module 1 with respect to stack trace and how the stack trace runs through the things that it needs to run through to get the job done and to run the code it needs to run. So when we're looking at our stack trace, we're looking at the way our code flows. Now, for all intents and purposes, I want to open up a C that I've used before. So we'll open this one up. And let's start off with the easiest part of flow control, and that's if-else statements. What are if-else statements and how do they work? In this class, once again, I'll be using W3 School's Geeks for Geeks and Tutorials Point, as well as Programmees, to talk more about what this actually means. So if you look at most programming languages, you'll find that if statements are the same no matter what you do. And in the end, the syntax is somewhat the same. You have ifs, you have else ifs, and you have if else. There is the argument that you can make if else, but in the end, really, where we really want to be is we don't want to have if statements that have long branches that are hard to maintain. So in the end, we normally stick, one second, with our ifs. All right, so let's talk about that for a second. So let's use an example. We'll use an easy example. We'll try to measure whether or not an integer is the number that we want it to be. So before we do that, I want to talk a little bit about how we're going to, from now on, get data. So we're not going to use variables that we preset to get data. As a matter of fact, what I want to do is I want to use what's called the scan function. And the scan function allows us to ask the user for data. So in this case right now, we're going to say before printf, we're going to say scanf. Right, there it is. And then what we want to do is we want to get data back from the user. So in this case, in this way, we're going to say scanf, and I did a little bit of string interpolation. I don't know if it was in this module or not, but we're going to do string interpolation here. String interpolation is a form of string concatenation. So string concatenation, if I can show you really quick, string. Actually, I think it's char or st. Oop, is that it? I don't remember how I did this. Char. I think that's it. And we can say str for string. That's the name of our string. Will it let me do that, or is that a reserved word? Brackets are not allowed here. That doesn't make any sense. Okay. And then what we're going to do is I'm going to put a semicolon there. And then we're going to say, oh, I don't know. Yeah, I was right. I was right the first time. I did that wrong. It's like that. Char string array. And then we'll say name. Now, if I wanted to concatenate, or if I wanted to save a string to this specific thing per se, and what I actually am going to need, do I need another import, or is it going to be okay? Well, I think it'll be fine. So we're going to comment this out real quick, and we're going to say John, and that's the name that we want to use. Now, of course, it's crying about it. It's probably going to not work, and that is due to the fact that I didn't put any numbers in here, and I don't want to. I actually want it to declare the string on its own. I don't want to predefine how big the string actually is. Now, please understand that when we're doing a character array or a string, that you have to define how big the string is, and I don't want to do that. I want this to be a dynamically generated string. So, one second. Let's see what I'm doing wrong here. I'm doing nothing wrong. So, it's the fact that I had that. And that should be it. So this is called, one second. Okay, cool. So there we have John. Now, if I wanted to print this, right, I could theoretically say printf, right? And then I could give it the string that I want to print, like this. So I can say, instead of putting in John here, or even instead of printing it directly like this, I can print str. And what should print is John. Let's see if that works. There it is. It printed the string John. That's great, But that defeats the purpose of the string interpolation, because with string interpolation, instead of doing this, so this is string first name, and then char str last name. Right here, I'm using camel case with the first word being all lowercase and every subsequent word after that, or every subsequent name after that being uppercase. I can say John Smith. Now I have two strings, right, character arrays. And if I wanted to combine them, I can say first name plus last name, str last name. And we're going to go over strings in great detail in the strings module. I should be able to concatenate both of these. I don't think I can concatenate them as char arrays, though. Either way, I don't have to do it this way. This is called string concatenation in higher level languages. We're not going to do that here. We're actually going to interpolate the string, which means I'm going to take each of these variables. I'm going to name them in order, separated by commas. So string first name, string last name. And based on where these variables are, I'm going to use string interpolation to place them. So my name is string interpolation for the first variable. That's for the first variable, str first name. This is for the second variable, str last name. Now, I'm only going over this right now because I want to talk about strings and I want to use strings, so I need you to understand what I'm doing. So if I put these two together, I get my name is John Smith down here, and that's correct. My name is whatever's in this variable, whatever is in that variable. Now, %s means cast this variable as a string. You might be saying, but it's already a string. But that doesn't matter. Printf needs to know this needs to be a string in the actual string that it's building, because each of these strings are what we call immutable. Now, I'm not going to get into that right now. I'm not going to even talk about immutability at the moment. I just want to show what that does. All right, so with that being said, let's jump back into if-else. So instead of these being strings, what I want them to be, however, are integers, so we can do some quick maths. So I wanted to show off string interpolation because we're going to use string interpolation in scanf. And why are we using string interpolation in scanf? We're using string or a reversed way of string interpolation because I want the values that sit in scanf. Now, I did say this before. I don't really want you guys to do things like this, but we're going to do this anyway. So int x, int y. Now, obviously, these don't have values associated with them. As a matter of fact, they have values of null. All right, null means nothing. You might be thinking that the number 0 means nothing, but the number 0 is a character in the ASCII2 library. It is represented by a hexadecimal number. Therefore, I don't want 0. The default value for an integer is already 0, but I want to make sure the values that I'm saving are adequate. So I'm going to say equals 0, equals 0. Now those values, these specific ints are no longer null. They're initialized with a value. Even though that value is 0, it's still initialized with a value, and that storage location is not foobarred. Great. So now what I'm going to do is I'm going to ask the user for data. So this is there are two specific values here. So what I want to do is I only want one. We're going to get rid of 1. We're going to say, okay, initialize int x to 0, and then I want you to assign to x the value that the user puts here. Assign to x, this is the variable that we created, x, or we can say first number, right? Assign to the variable first number, all right, what's in scanf. And then I want you to print, or actually, we already have a printf here, let's not be daft. The number is, and then we can say first number. Great. Now, what should happen when I click this run button is that the first number should initialize at line 4, and then at line 6, the program should stop and wait for the user, me, to put a value into the console down here. And then when I click enter, when I hit enter, then, or I hit return, then the next couple of lines should run. Here we go. Now, first things first, it stopped, but notice that nothing was there. Let's go ahead and stop this for a second. Let's make this more elegant. So let's say printf, and we'll say, let's prompt the user to do something. Please enter a number between 1 and 10. Now we have a prompt. We didn't have a prompt before. Now, the scanf property or the scanf function doesn't automatically allow you to enter a specific prompt. You have to make that yourself. And so with the printf function, we're going to print something, and the scan function will wait for a reply. The scanf function is specifically waiting for a number. So if I try to enter anything other than a number, it should fail. Now, this didn't fail per se. It didn't fail the way I thought it would. I thought this was going to throw an error saying you can't assign a number or a letter to a number. But it failed in a way that makes a lot of sense. What I can't do at this moment is I can't assign this to that because this is an integer and I entered an alphabet, right? So it ignored it. It completely ignored it and said, okay, fine, then I'm just going to go with the 0 because I can't change that anyway. So let's run this again. And this time, let's say 1. And there you go. The number is 1. Everything works just fine. Great. Cool. What happened? At line 4, the variable first number of data type int was assigned the value of 0. 1 equals sign means assignment. 2 equal signs means equality. So this does not mean first number equals 0. This means first number is being assigned the value of 0. At line 5, the printf function fires, and this string is printed to the console so the user knows what to do. The scanf function then fires next, and it waits for a response. It's looking for a response as a number. If it doesn't get the response as a number, because this format specifier is specific, it wants a number. If it doesn't get a number, it'll just act like you didn't give it anything. And first number will contain the 0 that it had beforehand. And then it will print the number is blah. Well, there's a problem. Notice that we have an edge case. When you put in the letter D, you get 0. Well, the user might not know that first number equals 0. As a matter of fact, the user might assume that when you enter D, you get 0. And that's not what we want. We want to control user behavior. And we want to control the flow of the program. So let's go ahead and add some ifs, or an if statement. So when the scanf comes in, we need to check to see if it's still 0. If first number equals 0, then printf, please try again. Please enter only numbers and try again. Now, excuse me. If print first number equals 0, then we know that the user did not give us a number because first number was never reassigned a new value. We're using this variable, we're assigning it a value, and then the user is reassigning that variable a new value. That's what we're doing here. If the user doesn't give us a letter, or doesn't give us a number, give us a letter, then this will never get reassigned, as you saw here. It never got reassigned anything other than 0. That's a problem. We need to catch that edge case. That is called an edge case. What are edge cases? Edge cases are things we don't want our program to do, but are not evident when we're programming. It wasn't evident to us, or me for that matter, that if I put in a letter, I thought it was going to give me an exception and say, you're not allowed to do this, program, die, don't do anything else. But what actually happened was the program said, well, I can't cast that as a number, so I'm going to cast it as nothing. And when we did that, it ignored everything and it elegantly allowed us to see what was going on, which was quite nice. No gnarly error that popped up with the line, the static trace, and all that stuff. But it's still an error nonetheless. It's something we don't want. So what we need to do is we need to check, is first number still 0? If first number is still 0, then this edge case happened. And so we need to tell the end user that's not the answer. So let's try this again. We're going to run, and let's test the edge case. Let's put in a letter again. Let's put in a Y. What happens? Please enter only numbers and try again. So guess what? Our if statement fired. It did exactly what it was supposed to do. I'm pretty happy about this. It worked right. I wonder, I've not tried this yet. Can I debug in Rebel? I should be able to. I just don't know how. Debugger, yes, you can. Where is my side panel debugger? Ah, and we have a breakpoint. This is beautiful. So let's go ahead and debug. All right. So it says, if you want to debug, let's talk about debugging. What is debugging? Debugging is the art, the science, and the action of stepping through your code line by line to find out what the heck is going on. All right. So for now, what happened is everything above this breakpoint, I added a breakpoint by clicking on the left side of the actual line. Everything above this breakpoint is allowed to fire and run without me stopping it. But I want to stop here because there's a couple of things I want to see, right? So first things first, I'm going to give this the Y again. Let's do that use case one more time. Let's see what's happening. And we stopped. Now, we stopped at first number. Notice I can scroll over first number and it tells me what the value of first number is. And that's what I want to know. I also scrolled, I didn't scroll over scanf, and I don't think I'll be able to see the Y come through, but clearly I know that first number equals 0. So if I want to keep going, looks like that doesn't do it. Let's see if I can step into it. Next step. I next step and I went into the if statement. Why? Because first number does equal 0, therefore that is true, and if that is true, then run the programming block that's in here. If this if statement was connected to anything else, if there was an else if or an else, nothing else would fire in the if statement branch. Only this. Only that. So let's step again. I'm going to go back to debugger and step one more time. If you're in Visual Studio Code or Visual Studio, you can always click F11. It lets you step into. And now we're at the end of the code. And if we step one more time, that should end it. And the answer here is, should be please try again. Let's make it run. There we go. And there it is. Please enter only numbers and try again. Fantastic. Okay, that was right. But this is an edge case. Right now our code's not firing correctly because that's an edge case. So I can say else, uncomment that out, save, and if first number is anything other than 0, anything else, then I want you to print this bad boy. So let's do this, and let's give it the letter or the number 12. The number is 12. Now, here's another problem. We only want the end user to give us 1 through 10, but the program isn't checking for 1 through 10 because we didn't write that in. So we should write that in. Let's write that in right now. So I'm going to make another branch, and this branch is going to be else if. Right? Now, with an else branch, you don't need a condition. These are Boolean expressions. And I can combine multiple Boolean expressions if I wanted. And that would work. Now, what does this mean? That means and. So if first number equals 0 and first number does not equal 1, because this exclamation point means does not or is not, and this means equal to, right? So if first number is not equal to 1, do this. When you have an and operator in your if, that means that both must be true. Otherwise, if you have, that means that this must be true on the left-hand side of the and that must be true on the right-hand side of the and you can combine as many ands as you want. If I did an or, which is 2 pipes, all right, 2 pipes is or, that means that only one of these conditions has to be true for this to be true, all right? So and means both conditions must be true to be true, or means only one of the 2 conditions have to be true to be true. In this case, I don't want to do multiple Boolean or multiple Boolean expressions in the same, because this is a simple program. So else if first number is greater than 10, or first number is less than 0, print the number is out of bounds. Please try again. Great. And I use string interpolation here because I want that number to print in the string when I notify the user that their number is out of bounds. So I'm going to run this to see if it works. Okay, here we go. Oh yeah, I need a semicolon. Run. Great. Now, let's write a number that's out of bounds. The number 12 is out of bounds. Please try again. So this worked. But that doesn't really tell us much. So let's put an if statement. Let's put a, I apologize. Let's put a breakpoint here to find out what in the heck is going on. And let's debug. So here we go. Put a number in between 1 and 10. I'm going to put in the number 12 again because that's the same example and use case. That's the same unit test that I used before. I'm going to use that unit test again. 12. And now it stops. So what value sits in the variable first number in this debug session? The number 12. That means that this first if statement should not be true. And if I scroll over this equality sign, well, if I was in Visual Studio and I scrolled over that equality sign, it would tell me if it was true or false. In this case, it doesn't, but that's fine. We know that the number 12 does not equal 0, so this shouldn't be true. So what should happen is it should skip all the lines in between these two curly braces and jump down to the next Boolean expression. And there you go. It skipped this because this will only fire if that is true. Okay, cool. Cool. Is 12 greater than 10? Yes, it is. Is 12 less than 0? No, it is not. But because this is an OR expression in the middle, it doesn't have to be both. It only has to be one. So in this situation, this at line 12 should fire. And there you go. Line 12 did fire. Something interesting is about to happen. We know this line fires. We know what it does. That's fantastic. Let's step one more time. All right, we're going to step again. So it went beneath the printf, right? It's now on the 13. And it skipped the else. It skipped the else branch of the statement, of the if statement, because, well, it has a true statement, so it doesn't need to check the else. When any of these are true, it doesn't check the ones beneath it. Now that I've explained to you what if, else if, and else mean and how they work, I'm here to tell you that this is not what I would do in the real world. I would not branch if, else if, and else together. I do not like branches of if statements, if statement branches, because they can create what we call tertiary dependencies. Those are dependencies that exist that we don't know exist, and in the event that they do fire, they can then create edge cases that you already see we're trying to develop for. We're trying to develop a way. So in order to get rid of these idiotic edge cases, what you really want to do is this. If first number is less than 10, or actually we'll say less than or equal to 10, okay? Or first number is greater than or equal to 0, all right? These, excuse me, can be combined with equal statements, equal signs, to create a compound operator. So this is a compound operator up here for equality. I showed you is not equal to, and now I'm showing you less than or equal to, greater than or equal to, greater than, and less than. Now, the reason why I'm doing it this way is because all these ifs will evaluate no matter if the if before it is true. That's very important because now I get to see a lot of edge cases I wouldn't have seen before, number one. And number two, right now we're developing in the main. We're not developing in any other function. But in a perfect world, in the real world, we wouldn't develop all of this in one sequential program. We would modularize it by using functions to compartmentalize this code. So theoretically speaking, I wouldn't write it the way you saw, because if this was in a function, then if this turned out to be true, in order for me to not run anything else, I would return something. Return means go back where we came from, okay? Return that string, and what that essentially does is it breaks the code so it doesn't run anything else. Because we're sitting in the main, I can't do that as of yet. But shortly we'll get into functions so you can get an idea of how that works. Great. Let's run this, let's debug it and see what happens. Stop. And I want to start at the, yep, perfect. This time, what we're going to do is we're going to put code in place, all right? We're going to put a number in that's in between 1 and 10. So we'll choose 5. Directly in between, there's no questions about that. That is in between 1 and 10. You can't fight me on this. C'est la vie. All right, so 5. We hit first number. Well, first number variable equals 5 because that's what we put inside the console. Therefore, this is not true. This is false. this printf won't fire, and we'll get to the next if. There you go. We're at line 12 now. If first number is greater than 10, well, that's already false because it's not. Or first number is less than 0, well, that's also false. So these both are false, therefore this will also be skipped, and we're going to get to the next if branch, or the next if statement. And here we are. This is the happy path. This is what we want to happen. So I'm going to type this in here. Happy path. This is a unhappy path. And this is unhappy path. This means that they didn't put in a number. This means they didn't put in the right number. This means they did put in the right number, and that's what we want to happen. All right. This form of debugging is very important when catching very critical edge cases that can really cause catastrophic errors to your program. But in this case, let's keep going. So right now, we're here in the happy path. And there we go, line 17. We need to get to line 19. There we go. So this was true, therefore line 20 fires. So first name is 5, which will be saved or interpolated to %d. And down here, if I continue to go and I not stop, all right, I get the number is 5. And we're done. That is my crash course into if-else statements. If you like this video, please like and subscribe. Otherwise, I will be coming out with another lecture very shortly, so stay tuned. Otherwise, as I say in all of my videos, good luck, have fun, ciao.